Okay, and welcome back to part two, the impact of trauma. So, we're now going to spend the rest of our first part of our training discussing how trauma impacts individuals, including what happens to the brain during a traumatic event, how the past gets triggered in the present, and how trauma affects how we process information, how we control our emotions, and how we relate to others. This is just a quick summary of the main points that we want to make in the second part. So, first of all, we're going to talk about how traumatic events activate survival brain. Then, we're going to talk about how that survival brain gets activated or triggered by current trauma related cues or triggers. Third, we're going to talk about how that chronic activation of the stress response system over time does us harm. Fourth, we'll talk about how trauma can disrupt our attachment and future relationships. And then finally, we'll end on a hopeful note and talk about the brain's neuroplasticity throughout our lives, which enables us to learn new things, set down new neural pathways, and heal. We'll begin with how trauma activates the survival brain. So let's take a moment and reflect. Think about a time if you have ever experienced walking across the street and suddenly realizing that there was a car hurtling towards you. I don't know if this has happened to you. It has happened to me. If it's happened to you, I wonder what you remember happening in your body. Do you remember, say, your heart beating fast or starting to sweat or your breath becoming shallow and fast? How did you react? Did you freeze? Did you jump out of the way? Think about now what might not have been happening. Like, did you notice the colors and cars around you? Or did you look at your watch to see what time it was? Or did you think about, gosh, how did I get here? Where am I going? Why didn't I stop and look more closely for oncoming traffic? Did you notice that your stomach was growling and hungry for lunch or a paper cut that was bothering you earlier in the day? My guess is probably not, because in that moment, what you were attending to is that information that was most directly related to your survival. And as we'll learn, that experience of heart beating and shallow breath and narrowed attention and altered perceptions of pain, all of that is part of the body's adaptive stress response system, which really prepares us to act when we're confronted with danger and anything that threatens our survival. So part of that adaptation of the stress response system is that we react without thinking. And that's an important point we're going to come back to. In moments when we believe we're in danger, that higher order thinking regions of our brain are circumvented. They're kind of temporarily taken offline. So we're going to go through this response now in a lot more detail. We're going to talk about some different structures within the brain. When you think about it, our brains are incredible miracles when you consider everything that they have to do. They have to generate internal signals that tell us what our bodies need. They have to create a map of the world to help us move toward meeting those needs. They have to generate the action and energy we need to get there and warn us of danger and opportunity along the way and adjust our actions based on what the moment demands. But the most important thing that our brain does, of the many important things it does, is to ensure our survival. And survival-based responses are automatic. They occur within seconds of a threat being detected. And again, they circumvent our higher order thinking. So there isn't time to stop or think about options or select the best course of action. We just reflexively react. And the brain is really hardwired to remember and to respond very quickly to any potential threats. So we're going to kind of take a top-down approach to looking at some different brain structures, and we'll start with the prefrontal cortex, sometimes called the thinking brain. This is the outer layer of the brain, and it's the last to develop and continues to develop well into young adulthood. The prefrontal cortex is responsible for what we think of as executive functioning skills. So abstract thought, logic, factual memory, planning, the ability to inhibit action so that we don't behave impulsively. It really helps us to consciously control our emotions and behaviors. So, for example, if you're feeling like turning off this training and, going and doing something that seems more fun, but you say, no, I've got to do this. This is part of my obligation for work and for serving the people that I serve. And so you say, no, I'm going to stick with it. That's your prefrontal cortex that's helping you to consciously control your emotions and your behavior. The frontal lobes are also involved in language, both receptives, our ability to understand what someone's saying to us, and expressive, our ability to relay information to someone else. It's also sometimes called the seat of empathy. We have mirror neurons that pick up on another person's emotional state or intentions and help us to adjust our behavior accordingly. What I want you to keep in mind is that when the stress response system is turned on, that this part of the brain is temporarily taken offline. And so all of these higher order thinking skills are the ones that take a backseat when the brain detects threat and responds to ensure our survival. One area in the prefrontal cortex that I want to call attention to is called Broca's area. You may remember that this is an area of the brain that's responsible for speech, and in particular for producing speech. You may have heard people who have been through traumatic events talking about being scared speechless, or being unable to talk or describe what's happening, like a speechless terror. This is not just a metaphor. People are actually describing what's happening in the brain, that this area shuts down and they can't put words to what they're experiencing. So keep in mind that when a person is triggered and we ask them, hey, what's going on with you? Tell me what's happening. They may not actually have the words to do so. Now, if we go deeper into the brain, into these subcortical regions of the brain, we will find structures that are involved in the body's defense or survival-based responses that are activated when we are under threat. And this includes structures in the limbic system, like the amygdala and the hypothalamus. These regions of the brain are considered more primitive. They're sometimes called the mammalian brain because we share them in common with other mammals. And this is really the part of the brain that is the seat of emotion and the monitor of danger. And it's very sensitive to experience and shaped in response to those experiences. This area, along with what we call the reptilian brain, which is located in the brainstem, an even more primitive structure, and is responsible for all the things a newborn can do, like eating or sleeping or regulating temperature. Those two areas, the reptilian brain and the mammalian brain, so this limbic system area along with the brainstem, this makes up the emotional brain. And during a traumatic event, when a person feels threatened and overwhelmed, it's these regions of the brain that take control. And these regions of the brain, this defense circuitry, initiates these automatic behaviors that are designed to protect us from harm, our survival-based responses. And that includes things like fight or flight, but also it includes responses that we call surrender responses, like becoming immobilized or dissociating. And those are invoked when fight or flight are not an option or don't work. We'll talk about that. This defense circuitry also leads to changes in the way that we perceive and process information, including sensations like pain, and also alters attention and memory processes. And as we've mentioned several times now, it also inhibits or impairs temporarily the prefrontal cortex. Another area of the brain I'd like to call attention to is the hippocampus, or the brain's memory filing system. So this is the part of the brain that's responsible for encoding information from short-term memory and transferring it into long-term memory. So, and especially the memories of life events. So if I asked you, for example, where you were on your 21st birthday, and you could remember, that's your hippocampus at work. The hippocampus also encodes the emotional context of events. So, for example, if I asked you, where were you and how did you feel the first time that you were kissed? Most people have a memory of a reaction, good, bad, or otherwise, that has some kind of emotional component. As you can see, the amygdala and the hippocampus are right next to each other. And memories with intense emotion are filed more easily and may be very hyper-focused, but at the same time may be more incomplete and fragmented because of the way that that trauma affects what we pay attention to and what we then later encode and store for later retrieval. The hippocampus also relates new learning to old learning, and it works with the dorsolateral part of the prefrontal cortex as a timekeeper to help us understand the context of what's happening and that something won't last forever. And as we'll learn, it's one of the structures that often looks different in the brains of people who have experienced trauma, and particularly chronic trauma. And so when the hippocampus breaks down, it makes it much more difficult to take an experience and store it in long-term memory as a coherent narrative that's located in a particular time and space. And it becomes more likely that that memory will actually feel like it's got no beginning and ending, and it's kind of going on and on and on forever. Next, I want to talk about the thalamus. The thalamus is a structure that you can think about almost like a cook who takes in a bunch of different ingredients. In this case, the ingredients would be different kinds of sensory information that's coming in through the senses, mixes it up, and then integrates it into a coherent experience that allows a person to understand, hey, this is what's happening to me right now. So, for example, if you think about the experience I have when I wake my daughter up in the morning. So I wake her up, and what does she experience? Well, she can feel the touch of my skin. She can hear me talking to her. She can see the light that's peering through her window. She can smell her pillow, and her thalamus takes all of that sensory information and integrates it into say, this is what's happening to me. My mom is waking me up. And then that information gets transmitted down to the amygdala to make sure there's no danger. And then also up to the frontal lobe that says, okay, now what do I need to do based on this information? Okay, I need to get up and start getting ready for school. The road to the thalamus is a little bit faster than the road to the frontal lobe. So for example, you may be walking down the street and see a coiled up object, skinny object, and it goes to your amygdala first, that sensory information through your vision. And your amygdala says, it's a snake. And then it goes up to your frontal lobe, and your frontal lobe says, oh, put the brakes on. Nope, it's not a snake. It's just a coiled up rope. So there's no need to get excited about this. But when the thalamus breaks down, as happens with trauma, what happens is that memories are stored not as these coherent stories of this is what's happened to me, but rather as these fragmented sensory inputs. So instead of my mom was waking me up, it may get stored as like bright light, cold air, loud voice. Again, without that accompanying narrative that helps a person to make sense of the experience. Also, when the thalamus breaks down, a person can no longer distinguish between sensory information that's important and information that can be ignored. So you feel you're kind of like in sensory overload all the time. Now, when that amygdala, so the information comes in through the senses, gets mixed up by the hypothalamus sends it to the amygdala, and the amygdala says, hey, there's a threat here. Then that information is sent to the hypothalamus and the brainstem. And we have the activation of the autonomic nervous system, which is comprised of the parasympathetic and the sympathetic branches. So in this case, we have the activation of the sympathetic branch of the autonomic nervous system, which is really revving the body up for action through the release of stress hormones like adrenaline. So now we have this activation of the autonomic nervous system, and that part of our nervous system controls all of our involuntary functions like digestion, heart rate, blood pressure. Again, it's comprised of the sympathetic and the parasympathetic branches. The sympathetic branch gets us revved up for action, and the parasympathetic branch calms us down. So again, when the brain detects a threat, then it's the sympathetic system that gets activated. And so what happens is that heart rate and blood flow and blood pressure go up so that the muscles have blood and oxygen to be able to respond by running away or hiding or fighting back. Our breathing rate goes up in order to deliver oxygen throughout the body. Our muscles become tense. Our energy is broken down so that we feel sort of this surge of energy. Our pupils are dilated so we can focus more clearly on present danger. And long-term projects in the body like digestion may be sort of put on hold while the body is invoking this stress response system. So this is really what you can think of as that kind of classic fight or flight. And we also have the activation of the HPA axis. So the hypothalamic pituitary adrenal axis, which is responsible for sustaining the body's state of being alert over time, again, through the release of stress hormones. And if you want to watch a 2-minute kind of quick synopsis on the HPA axis, you can follow this link right here.
Welcome to 2-Minute Neuroscience, where I explain neuroscience topics in 2 minutes or less. In this installment, I will discuss the HPA axis. The hypothalamic pituitary adrenal, or HPA, axis is best known for its role in our body's reaction to stress. The HPA axis includes a group of hormone-secreting glands from the nervous and endocrine systems, the hypothalamus, pituitary gland, and adrenal glands. The hypothalamus is a small neuroendocrine structure situated just above the brainstem that controls the release of hormones from the pituitary gland, a hormone-secreting gland that sits just below the hypothalamus. The pituitary gland can release hormones into the bloodstream to reach a variety of targets. In the case of the HPA axis, hormones released from the pituitary gland travel down to the kidneys and influence the secretion of hormones from endocrine glands called the adrenal glands, which sit on top of the kidneys. The primary function of the HPA axis is to regulate the stress response. When we experience something stressful, the hypothalamus releases a hormone called corticotropin-releasing hormone, or CRH. CRH signals the pituitary gland to secrete a hormone called adrenocorticotropic hormone, or ACTH, into the bloodstream. ACTH travels down to the adrenal glands where it prompts the release of a hormone called cortisol from the cortex or outer layer of the adrenal glands. The release of cortisol causes a number of changes that help the body to deal with stress. For example, it helps to mobilize energy like glucose, so the body has enough energy to cope with a prolonged stressor. When cortisol levels in the blood get high, this is sensed by receptors in areas of the brain like the hypothalamus and hippocampus, which leads to the shutting off of the stress response through what is known as a negative feedback mechanism.
So again, let's just summarize. Information comes in through the senses. The thalamus kind of mixes it up, integrates it, and it's sent down to the amygdala and also up to the prefrontal cortex. It gets to the amygdala first. If the amygdala sounds the threat, it inhibits the prefrontal cortex and activates the autonomic nervous system for fight or flight, or as we'll talk about, it may abandon those responses because they're not possible and go into surrender mode. We'll talk about that in a second. The hypothalamus activates the HPA, the hypothalamic pituitary axis, to release stress hormones to maintain a high state of alert over time. And again, in a well-modulated response, the prefrontal cortex will tell the amygdala, hey, stop. It's not a snake, it's just a coiled up tube. And then the stress response system will go down, and the body will go back to homeostasis. But as we'll learn with trauma, and when it turns into PTSD, the prefrontal cortex is underactive and the amygdala is overactive. And so the amygdala keeps seeing threat and keeps overriding the prefrontal cortex, even when there is no threat present. So again, let's just summarize information. So how does all of this then prepare the body to respond? And what do we actually do? Well, typically the first response when a person experiences a traumatic event is actually to freeze. And during freeze, which is only a matter of moments, the body is in a state of high arousal and is sort of taking in information from the environment that it needs in order to figure out how to respond. And then the person will sort of jump into action. Again, a person is not under aroused at that moment. They're very hyper aroused. If fight or flight are an option, then that release of stress hormones will activate the sympathetic nervous system. Arousal will be high, prefrontal cortex will be impaired, and the person springs into action either by fighting back or physically running away. Being able to do something to defend yourself during a traumatic event is very important in terms of being able to recover quickly. As a quick example, I was the victim of an attempted mugging when I was in college and studying abroad. And the person who tried to mug me was actually younger. It was actually like maybe a 13 or 14-year-old boy. And I was much taller and bigger than this person. And without thinking, I just sprung into action and I actually started fighting back, and the boy ran away. And so I had some sort of residual like nightmares and intrusive thoughts about what happened and hypervigilance, but I did not develop PTSD as a result of that. And likely that was because of my ability to do something to protect myself. Now, had that person been bigger than me, had that person had a weapon that could have seriously hurt me, then fight or flight may not have been an option. And when fight or flight are not an option because we're trapped, because we're physically overwhelmed, because we're threatened by violence, or just because we perceive that there's no way that we can protect ourselves, then we will abandon fight or flight and we'll actually go into surrender responses, which I'll talk about next. So when the body is under threat and the person cannot run away, cannot hide, cannot fight back, think, for example, about children, then the body's best defense in order to prepare for injury and protect itself as best possible is these surrender responses. So these include responses like tonic immobility, which is when a person is literally paralyzed, they can't move or speak, but they're typically fully aware of what's happening to them. They literally can't move their body or say anything. In collapsed immobility, there is a sudden massive drop in heart rate and blood pressure. And so the person actually can lose consciousness. The body may appear sort of limp or floppy. There is, the lapse in consciousness. The one that you probably most typically see in, your practice is dissociation. And this is when the brain essentially disconnects one's conscious awareness from the terrible sensations and emotions that are happening and from the horrific experience. So, people will describe, for example, feeling like they were in a dream or in a movie or disconnected from their body or watching themselves from across the way. And again, this is the body's way of trying to protect itself from the horror of what the experience is when fight or flight or run away are not options. You can imagine how these surrender responses can lead to feelings of self-blame and self-criticism after the fact, when people may say, well, why didn't I do anything to defend myself? Well, why did I just lie there? Why didn't I even say no? And from other people too, you may get responses like, well, did you try to do anything to fight back? Did you try to get out of the situation? Those kinds of responses lack an understanding of the reflexive nature of these surrender responses, that these surrender responses, when they are invoked, they happen without conscious thought. They happen reflexively, and they happen out of the intention or aim to protect the individual. Let's take a moment now and think about how we might mislabel someone who presents in a state of fight, of flight, of freeze, or surrender. Consider the following case. Maria is a 13-year-old eighth grader. She most often appears disconnected and disinterested. She fidgets, avoids eye contact, mumbles when adults ask her questions, and mostly doesn't appear to care about anything. She seems to understand the material and sometimes does well in assignments, but refuses to engage with others during the school day. Teachers complain that she often puts her head down and attempts to sleep during class. This gets incredibly frustrating for adults who keep prompting Maria to sit up and engage. These power struggles frequently end with Maria either leaving the classroom or putting her head down for the remainder of the period. By background, you know that Maria experienced chronic physical abuse and neglect from her aunt, who she stayed with after her parents migrated to the U.S. When she migrated 4 years ago to the U.S. to reunite with them, they had divorced and each remarried and had new children. Now Maria feels like she doesn't belong anywhere. Take a moment and consider, what do you think the staff perspective might be if they didn't have a trauma-informed lens? What do you think Maria might be thinking and feeling and experiencing? And what do you think the staff perspective might be thinking with the trauma-informed lens on? Without a trauma-informed lens, staff might think Maria's lazy. She's unmotivated. She doesn't want to apply herself. She's just wasting her potential. And it's not okay for her to act like this. Even if she does well on assignments or tests, she can't behave this way at school. What do we think Maria might be experiencing? Perhaps she thinks, no one really cares what happens to me. I can't deal with more expectations from adults. What's the point in trying? Adults don't understand how hard my life is. And I can't trust anyone, even if they say they're just trying to help. What do you think staff might be thinking if they have their trauma lens on? They might be thinking, Maria's focused on survival. She can't expend a lot of energy on learning and being curious about new things because she's in freeze mode most of the time as a way to manage her overwhelming feelings. From this perspective, we see Maria as doing the best that she can and understand how her behavior right now is really rooted in initially trying to adapt to hostile environment and experiences. So it really posits Maria as having strengths and just trying to do the best that she can versus having deficits and being a broken person. Let's look at one more short vignette. Jamie is a sophomore in high school and is constantly in trouble at school. He has a very short fuse and will quickly become aggressive when adults call him out on his behaviors and set limits. Jamie is particularly confrontational toward male staff. His pattern is often to begin by challenging a teacher during class, either questioning what they're doing or refusing to participate. From there, things often escalate as Jamie becomes loud, paces around his desk, and eventually is ordered to leave the classroom. Once in the hallway, he becomes disruptive to other classmates and has a lot of difficulty calming down. By background, we know Jamie has witnessed domestic violence and gun violence in his neighborhood, and he was bullied when he was younger. Jamie's grandmother cares for him at her home, but often says that she's not sure if she can continue to have him stay with her. Again, ask yourself, what would staff think about Jamie without trauma lens on? What do you think Jamie is experiencing? And what do you think staff might be thinking about Jamie with their trauma lens on? Without a trauma lens, staff might think Jamie's just trying to get out of things he doesn't want to do. He's disrespectful and he purposefully tries to make adults look foolish. He needs to learn he can't act like this without severe consequences. And he needs to learn that adults are authority figures and he needs to respect them. What do we think Jamie might be experiencing? Might he be thinking, adults are frightening. They're unreliable. You can't trust them. They may be out to get me. And I need to get them before they get me. I feel scared and out of control most of the time. What does staff think if they have their trauma lens on? They might be thinking, Jamie feels threatened and unsafe right now. Jamie doesn't know how to connect with adults in a positive way, even though he may want to. If I create a confrontational scene with Jamie, that's not going to help, and it's just going to confirm his beliefs that adults are unsafe and that they cannot be trusted. Again, we can see here how putting a trauma-informed lens on and understanding his behaviors now through how he initially adapts and currently adapts to experiences of trauma and adversity really changes the way that we interact with Jamie.